In this example, we look at a factory that requires a lot of water in its production process, and we will determine for a specific design of the rainwater system how much water can be reused effectively and how much water should be brought in from another source. So here we have all the information. So the paved surfaces of the company will drain towards a buffer, and water will be pumped from this buffer back to the company to be used in its production process. There is an expected reuse of 240 cubic meters per day from Monday to Friday, but not in the weekend and not during construction leave in July. And the buffer is also connected to an existing sewer system. And we will model this as one reservoir in Sirio. So this is the draining surface. This is the buffer with a certain capacity. There is also a true flow to the existing sewer system, and the pumping station will be represented by reuse. Note that once water is reused, so is pumped back into the company, it is removed from the system itself. So here we have some general parameters. In total there is a contributing area from slanted roofs of 6.5 hectares. We'll use a runoff coefficient of 0.9 instead of 0.8 because it's a slanted roof, and we will also disable surface storage. So if you want to know more about these parameters, please check the manual of Sirio. We also have a true flow. It's an orifice with a diameter of 150 millimeters. Its invert level is located at 1.5 meters above datum, and we use the default discharge coefficient of 0.9. We already have a design for the buffer. It's a very simple design with a rectangular cross section. The bottom level is at 0 meters above datum. The area at the base is 2,500 square meters, and it's a square, so the longest side is 50 meters. The overflow is located at 2.36 meters above datum, and this will determine, of course, then the capacity of the buffer. We have a reuse from Monday to Friday of 240,000 liters per day, with no reuse in the weekend and not in July, as there is no action in the factory then. Now we have two options for the infiltration. For the first scenario, we're going to investigate with the infiltration how the infiltration will impact the potential reuse if there is infiltration allowed through the sides and the bottom of the buffer. We also have the infiltration capacity, which was measured. And in a second scenario, we will look at how much water can be reused if there is no infiltration at all. And now I can fill in all these parameters in Sirio. So first I define the simulation parameters, and I exclude the surface storage. So for more information, please check the manual on this parameter. And I can already define the infiltration capacity, which was 20 millimeters per hour with a safety factor of 2. And then I can go to my model and select a random reservoir. And for this, I will look at the infiltration. So including infiltration. This is our first scenario. And then later on I will copy it and look at the second scenario without infiltration. So then I specify the general parameters. So we had a runoff area of 6.5 hectares with a runoff coefficient of 0.9. And of course there are no parcels connected. I will fill in the capacity once I've defined the dimensions of my reservoir. Then I don't have to calculate the capacity manually. Then I add my connection, my true flow, so it's a connection to the sewer system from the buffer, and we had an orifice in this case, and then I define the parameters using this step. So it had a diameter of 150 millimeters and an invert level of 1.5 meters above datum, and I simply leave the discharge coefficient default. Then I can define my reservoir dimensions. It was a very simple system, a simple buffer with a rectangular cross section, so I use option 1. And I fill in the required parameters here at the bottom. So it had a floor area of 2,500 square meters, and the level was located at half a meter above datum. Now I'm also going to simulate infiltration through the sides, and as you can see here, we need an additional parameter. It's this one, the longest side length. In this case it's a square buffer, so it has a width and a length of 50 meters. Save and exit, and these parameters are saved now. I then define infiltration and drainage through the bottom and the sides, so I select both. The bottom I still have to specify this one, it's 2500 square meters. For the side infiltration I simply use option 1 through the side areas. And then I can finally define my reuse. So I define it through this interface, and it had a varying reuse per day of 140,000 liters per day during the week, but no reuse in the weekend, so I leave those at 0. And then I'm also going to add a monthly variation. So this reuse that I define here is being multiplied by the factors that I define here for each month. So there is a reuse in every month except for the month July. So then I set this factor to 0, which means that I will have no reuse in the month of July. Then I also include some evaporation. Sirio will calculate the area, and I do not have an additional incoming flow. And then finally we still see that there is one parameter missing, it's the capacity. So the capacity will determine the overflow level. But we can also reverse our calculation, and we know that in this design our overflow level is at 2.36 meters above datum. I then press update capacity. We can simply ignore this message, and then the corresponding capacity is being calculated. So now I've included all the parameters for the scenario with infiltration, and now I can define the second scenario without infiltration. And this can easily be done using the button copy reservoir. I select the reservoir that I want to copy, and I copy it to a new reservoir. So I'll write here without infiltration, without a dot. And then I simply exclude infiltration and drainage, and then everything is defined. And I can simulate my model, but here we can see that there are some validation warnings. So I will continue with the simulation. That's always possible if you have a validation warning, but I will also inspect the validation warning in the tab Overview. And here you can see that there are two cells marked in yellow, and for this we have an unexpected value, as you can see here. So Sirio can simulate the model, but it warns us for some unexpected values. And then if you click on the cell, you can get the validation warning here below. So in this case, Sirio warns us that the capacity is very large, and you might have mistaken cubic meters with liters, but in this case it's not, it's actually what we want, so this is correct. Then let's look at the simulation results. And here we see the mass balance on the left, showing where water is coming from and where it's going to. Now the column total is the sum of all the elements in our system, and in fact we were looking at two alternatives here, so this does not have any physical meaning. It's the sum of the two buffers, so we will remove this column. We also do not make use of the parcel module, so I'm also going to remove these two columns here. And then we have our two systems here. So we see that, of course, the incoming rainfall is exactly the same. That's also the only source that we have. And in reservoir 2, including infiltration, we have a lot of infiltration. In fact, 88% of all the infiltration, of all the water that is flowing out of the buffer is going through infiltration. And only 12% is being reused. So if we would impede infiltration, we get a completely different view. We see, of course, that there is no infiltration. Evaporation is also very limited. The true flow rises, so 31% of all the water that's coming into our buffer is passing through the true flow, while 69% is being reused. So that's much more reuse, almost a factor of 10 if you look in absolute values that can be reused more. Now let's look at some overflow statistics. You see here, when we include infiltration, that there is no overflow, not one overflow event in 100 years. But if we exclude the infiltration, we see that we have 5 overflow events in total. So that's already an indication that our reservoir 3 will be filled more often than our reservoir 2, which has infiltration. Here you can also see the degree of filling. So without infiltration, you can clearly see that that it's almost always filled. We see that our buffer is only a few percentages of time empty, and here you can clearly see that we have an overview at this level. So here below this level, so for the lower filling degrees lower than 65, our buffer will be emptied via the reuse, while above 65 we have a very quick storage that will be filled and will be drained via the orifice. If we include infiltration, we get a completely different image. We see that the maximum filling degree is only 77%, and the receding limbs are much steeper compared to the scenario without infiltration. And in fact, 80% of the time our buffer will be empty if we would allow infiltration. So if we want to promote reuse, this is definitely not a good design. There is too much infiltration. We can also look at this in a bit more detailed. If we ask for time series for a specific element and then ask for reuse, we can actually see here the absolute volumes that are being reused and the missing volume to meet the requested reuse. And these are volumes over 100 years. So in fact you should divide them by 100 to get the average reuse or average missing volume per year. So we see here that we can effectively reuse about 5,800 cubic meters per year if we would include infiltration. But if we would impede infiltration for reservoir 3, this rises to about 33,000 cubic meters per year. So using Sirio, you can easily optimize your rainwater design to promote water reuse, and you can also investigate the impact of allowing or impeding infiltration.